Now we're going to go through a second important class file, which is going to be called vector math.
Xcode. Show project navigator. Audio layer.swift. Vector math.swift. Swift source.
So we got vector math. So you can either create the file if you want, or you can just look through it so I can explain, directly how all of this works. So I'm just going to go inside with Command J.
Move focus to measure ellipses. Source code insertion. ///////// new line. Import foundation. Import scene kit. New line.
So we've imported SceneKit because the objects we're dealing with are actually come from SceneKit, and they're the ones which need to be extended in order for us to do our mathematics efficiently without having to go through all sorts of dot notations and so on.
Func plus left parent left colon. SCN vector 3. Right colon. SCN vector 3 right parent dash greater SCN vector 3.
Okay, so func plus, that's the plus operator. And so it's an operator function. That means what's going to happen is that we're going to take two SCN vector 3 objects. We got the left and the right one, so those are the labels, and we're going to return another SCN vector 3. What this does simply is to take each component of the left and right SCN vector 3 objects and then add them, and then return a new SCN vector 3 with the result.
Left brace return SCN vector 3 left parent x colon. Left dot x plus right dot x. Y colon. Left dot y. Z colon. Left dot z plus right dot z. Right brace.
In this one, I didn't take into account the y because we're just kind of dealing with the x and the z axes.
New line. Func dash left parent left colon.
And now we do the same thing with the minus.
New line. Func dash left parent left colon. SCN vector 3 right colon. SCN vector 3 right parent dash greater SCN vector 3. Left brace return SCN vector 3 left parent x colon. Left dot x dash right dot x. Y colon. Left dot y. Z colon. Left dot z dash right dot z.
Okay, left dot z minus right dot z. So SCN vector 3 have three values inside, x, y, and z.
Right brace, new line. Func plus equals left parent left colon. In out SCN vector 3 right colon. SCN vector 3 right parent.
So now plus equals. So this is kind of like a coding convention. When you do plus equals, then what say a plus equals b, it would mean a equals a plus b. But it's faster just to write plus equals.
Func plus equals left parent left colon. In out SCN vector 3 right colon. SCN vector 3 right parent left brace. Left equals left plus right. Right brace, new line. Right brace, left equals, func plus equals left parent left colon. In out SCN vector 3 right colon. SCN vector 3 right parent left brace.
Okay, so the left one is the in out. In out meaning that the left one is the value which is going to be assigned the new value. I mean, it is the variable which is going to be assigned the new value. And that's why we set up an in out keyword to say that's the one which we're going to assign the actual values on. And you'll see it here.
Left equals left plus right.
Left equals left plus right.
Right brace, new line. Func dash equals left parent left.
And we do the same thing with subtraction.
Left equals right brace, new line. Func plus left parent left colon. SCN vector 3 right colon. CG float right parent dash greater SCN vector 3 left brace.
Now on this one, we're doing the same thing, but with scalar values for the right one. So CG.
New line. Func plus left parent left colon. SCN vector 3 right colon. CG float right parent dash greater SCN vector 3 left.
In this one, so what we want to do is we want to take every element of the vector, so x, y, and z, and we want to add it a CG float or a float number. So that means if I have, a equals a vector with which is 1, 1, 1, and the right one is a scalar or just a real value, just a value. So like any number you can pick, 10.5, 5, 230,000, 50 million, it doesn't matter. It will assign that 50 million, that value to every component inside the vector.
Return SCN vector 3 left parent x colon. Left dot x plus right. Y colon. Left dot y. Z colon. Left dot z plus right right parent.
There you go.
Right brace, new line. Func dash left parent left colon. SCN vector 3 right.
And we do the same thing with the subtraction.
Return SCN left dot z right brace, new line. Func star left parent left colon.
We can also do that with multiplication. That is good for actual creating a scalar multiplication of a vector, because what we're going to do, we're going to take a vector and make it a unit vector. So which that means it has a magnitude of 1. It has a distance of 1. That way what we can do is when we multiply it with a scalar value, if we want, let's say, to go through 50% of that vector, of that distance, then we just have to multiply that unit vector by 0.5. So that'll be useful when we actually go through the actual code inside the game view controller.
Return SCN vector 3 left parent x colon. Left dot right brace, new line. Func slash left parent left colon.
And we can also do division, and that will be useful for when we want to create the unit vector.
Return SCN vector 3 left parent x colon. Left dot right brace. New line. Func plus equals left parent left colon. In out SCN vector 3. Right colon. CG float right parent left brace.
Now we do the same thing with plus equals and minus equals between a vector and just a value, a number.
Left equals left right brace. New line. Func dash equals left parent left colon. In out SCN vector 3. Right colon. CG float right parent left brace. Left equals left dash right. Right brace. New line. Func star equals left parent left colon. In out SCN vector 3. Right colon. CG float right parent left brace. Left equals right brace. New line. Func slash equals left parent left colon. In out SCN vector 3. Right colon. CG float right parent left brace. Left equals left slash right. Right brace. New line. Slash slash mark colon. Distance.
So these, I'm sure you're going to be keeping them over time. I have, because they're very, very convenient. And those are all kind of, placed into their own file. They don't take much space, and you can use them as boilerplate when you want to quickly, just whip out your toolbox and do some things in prototype or, have some fun.
New line. Slash slash mark colon. Distances, magnitudes, and dot products.
Here we got the distances and magnitudes. So
New
the
line.
distance, what you want to do with the distance is, if you have a vector, say, let's see, well, the smallest distance is the unit vector, which is, for instance, for a two-dimensional vector, you have the x and y component. So x usually is horizontal line and y is vertical line, and you want the distance of that at a certain point. So if I have 1, 1, what we're effectively doing is, if you look at a right angle triangle, right, which starts at the point 0, 0, which is the origin, and horizontally goes 1 unit and vertically goes 1 unit, what you're effectively doing is actually figuring out the hypotenuse, and that is Pythagoras' theorem, which is the square root of the sum of every element squared. Right? So if you have x and y, that would be the square root of x squared plus y squared. And in this case, it'll be square root of 2.
Func distance left parent left colon. SCN vector 3. Right colon. SCN vector 3 right parent dash. Greater CG float left brace.
Okay, so the signature is basically distance. So we take two SCN vector 3 objects, which is R3 or 3-dimensional, and we return an actual value, which is the distance. We call it the magnitude.
Return CG float. SQRT. Pow. Double left dot x dash right dot x. 2 right parent plus pow. Double left dot y dash right dot y. 2 right parent right parent right parent. Right brace.
There you go.
Double left return CG float. SQRT. Pow. Double left dot x dash right dot x. 2 right parent plus pow. Double left dot y dash right dot y. 2 right parent right parent right parent.
In this case, what I've done is left dot x and y dot y. Left dot like a 2-dimensional one. So I just take 2 bits instead of all of the 3 components, because I just want the distance of 2 components, not all 3 components. But we can put it for 3 components for whatever amount we want.
Right brace. New line. Extension SCN vector 3 left brace.
Okay, now ESCN vector 3, we would like to be able to assign it a very easy way of calculating distances.
Var length return var length colon CG float left brace.
So var length, CG float, and that is just the calculation of the distance between 2 vectors.
Return SQRT, self.x asterisk, self.x plus self.z, asterisk, self.z. Right brace.
There you go. So we got that length, self.x and self.z.
Space, var normalize colon, SCN vector 3, left brace.
Now, normalize, that's to create the unit vector. Again, the unit vector is the best way to actually calculate distances. So 0.5 is halfway, 0.25 is a quarter of the way. And this is how we actually increment each step of the way, because we know that since a unit vector takes the normalized vector, takes the distance between 2 points and normalizes it in the way that we have a unit of 1. It's kind of hard to figure out what halfway of 4.2798 is. But if we normalize it to 1, then halfway of it is simply 0.5. This is how we normalize it. So what we do is we actually take the components, and then afterwards we divide it by the length itself.
Return self/length.
All right, self/length.
Right brace. Return var normalize colon, SCN vector 3, left space. Var norm, return self, right brace.
And because we had this slash between SCN vector 3 and a value. So that means that every element inside the vector is going to be divided by the length or the magnitude of that vector. Okay.
Space. Space.
If you have some difficulties with this, you can go back onto the blog, and I have put some reference websites where you can actually take a look at some of these concepts, because they're very, very essential for programming in 3D.
Func dot left parent other colon. SCN vector 3 right parent dash CG float left brace.
So dot is a dot product. That is to kind of give you an understanding of the angle between two vectors. If two vectors are perfectly perpendicular, then that means the dot product is going to be 0. And then you would have 1 minus 1. And all of these kind of gives you an understanding of what the actual angle is, so that you can get the rotation right.
Return self dot x asterisk other dot x plus self dot z asterisk other dot z. Right brace.
Okay. And this is performed by actually multiplying each element of both vectors to get both vectors. So say we have the vectors u and v, and both of them say have x and y components, then u dot x and y dot x will be multiplied. U dot x and v dot x, will be multiplied. Then u dot y and v dot y will be multiplied, and these will be summed up together.
Space. Right brace. New line. New line.
So this is all for the vector maths.